P.9 linear inequalities and absolute value inequalities. So you've been solving inequalities in algebra for a number of years, but the big difference we're going to do today is what we call interval notation. And interval notation is another way to write the answer set. So this is something we're going to use a lot in pre-calculus, so I want you to get used to it. First things first, I want to make sure I say this. You must put your numbers in order from lowest to greatest when you deal with interval notation, okay? So we have two ways we write interval notation. The first one is you can use parentheses, okay? If you use parentheses, this means it's not equal to, but it approaches this value, okay? But if you have brackets, and it needs to be clear that they're brackets, so nice and squared off, this means that it is equal to the number it comes up to, okay? Now, you can use a combination of them. You can have a left parenthesis and a right bracket, or a left bracket and a right parenthesis, or you can have two parentheses or two brackets. So you have those options. Okay, so this whole first chart that you see is just a lot of the different ways, and they're just showing us how we can write these different things. Of course, this is written without numbers. But the other thing they're showing you along with the interval notation, so you have interval notation over here, okay? And I do want to state out, anytime you use negative or positive infinity, it has to be the parenthesis because you can't be equal to that. So when you are equal to something, it has to be an actual value. And then you have set builder notation, which maybe you've done a little bit before. This is using the set, those funny brackets. And this is, when you read it, it says any value of x where x is greater than a or less than b. So in between those two values. Notice there's no equal signs. Since there's no equal signs, when you graph them, like on the right or on the left on interval notation, you have parentheses, okay? So this whole chart kind of goes through. It's something to refer back to if you're not sure of. One thing I do want you to see is that if it's all real numbers, instead of writing all real numbers, we would write negative infinity to infinity as our interval, okay? And then there is the empty set, null set, if there is no solution at all. But we're not worrying about that so much right now. It's just learning to write things in set notation, okay? So for our first examples here on the bottom of the first page, we want to express each interval in a set builder notation and graph it. I'm going to see if I can move this page up just a little bit higher. There we go. Okay. So set builder notation first. What is this parenthesis and this bracket telling us? So of our x's, so there's my fancy parenthesis, of our x's, that's how we start a set builder. It looks like x is going to be equal to 5 because of the bracket, so that means equal. And then it's going to be anything less than that because of the going towards negative infinity. So I'm just going to have one stipulation, x needs to be less than 5, and then I'm going to also put the equal to because of the bracket. And that's my rule for that one. So if x is less than or equal to 5, I would write it in their interval notation. Maybe it's even easier to write my number line first and say, well, here's 5, right? I'll put like a 4, 3, 2, 1, 0 here. A couple values there, and I want to be less than or equal to. So notice too, when we graph it, we use, instead of arrows now and stuff, we'll use this bracket, and then we'll shade everything to the left of it as well. Okay, so we kind of still shade, but we use the bracket or a parenthesis on the number line. All right, when I go to number 2, I'm going to do this slightly different this time. I'm going to do the number line first and then write the set builder notation. So we see these two numbers, which means those are the two numbers I'm going to put on my number line. And it looks like I'm including the negative 4, but it's my left limit. And I'm not including the 7, so I'm going to put a parenthesis. And then it's any number in between there. Okay, that's what that interval notation tells me. So when I go to write it in set builder, it's any x that is between negative 4 and 7. But I need to make sure my 7 is just less than, and my negative 4, though, is greater than or equal to because of the bracket. All right, and finally, for the last one here, I'm going to draw my number line again. I'm between 2 for my left bound and 8 for my right bound. Once again, super important on interval notation, we write the lowest number first, the highest number second, so that we can use those to just go straight to a number line. So make sure those are in order from smallest to largest all the time. I have a bracket on the 2 as my left bound, and a bracket on the 8 as my right bound, and I'm everywhere in between there. So that looks like in set builder notation, x is going to be every x between 2 and 8, but we're also going to do the equal to since I have the brackets, and I'll close my set. Okay, so that's just taking and writing kind of the same exact information 3 different ways, either on a number line, as a interval notation, or as a set builder notation. To be honest, the one we use the least is the set builder notation. We will use the interval notation a lot. So let's go to our second page here, and let's work on some of these. Okay, so the first thing we're going to do here, once again, I'm not solving anything yet, but I'm just going to find intersections and unions of 2 intervals. Okay, so a quick reminder that when we did this back in Chapter P, we are in Chapter P. When we did it earlier in Chapter P, U is union, and that means all, everything involved, right? If it's the upside down U, this stands for the intersection, and that means what they share, okay? So one of the easiest ways or best ways to start these problems is to start with a number line, okay? So I'm going to draw myself a number line here, and notice this time I have 2 intervals. Looks like I'm using numbers between 1 and 6, so 1, 2, 3, 4, 5, 6. All right. So the first one says, and I'm going to do a different color here just because I can, so hopefully it stands out. I am going to be between 1 and 3 in brackets, so my first one goes here between 1 and 3. My second one goes between, I thought I changed colors there. All right. Second one goes between 2 and 6, not including them. Okay, 2 to 6 here, and it goes in between here. And right now I'm looking at, I have the union, right? So I'm looking for all of them involved. So when I'm looking for all of them involved, I basically say, where's my far left? Well, it's 1. Where's my far right? It's 6. So I have everything involved between 1 and 6. That's my answer for my union between those 2 intervals. All right. So let's try number 5. I'm going to do a black number line this time. Looks like I go to negative infinity, but I have a value of 2, a value of 6, and a value of 9 here. So that's what I'm going to put on my number line. All right, first interval goes from negative infinity to 6, not including 6, and of course you can't include negative infinity. That means it's going on and on forever that way. There's no ending, so there's no including point. And then my second interval goes from 2, including 2, all the way up to 9. Okay? And this time I have the intersection, right? It's the upside down U. It says the intersection, which says I want to know where do they overlap. Well, it looks like we have the overlap of the blue and the red right there between 2 and 6. It does not include the 6, but it does include the 2. So we get a bracket at the 2 and a parenthesis around the 6. All right, third one here for our joining intervals. 2 and 4 are my only values, really. All right, the first interval says includes 2 and goes positive towards infinity. And the second one includes 4 and goes towards positive infinity. All right, and it looks like it's a union. So it's saying what do they have not in common, but what do they share? From their lowest to the highest, where do we go? Well, our left bound was at 2, and it goes all the way on to infinity. So infinity always needs a parenthesis, and 2 can be included on that. And that's because it's a union, okay? All right, questions? Hannah, anything? All right, ask in class. Thanks for listening. All right, solving linear inequalities now. Remember, an inequality in the linear form is like an equation, but instead of an equal sign, we have an inequality sign. So as far as solving it, we are going to simply solve it as we would an equation, and then we're going to make sure that we give the final answer will be an interval notation, okay? So let's go ahead here. On 7, it looks like I need to distribute on my left side. I get 4x plus 4 plus 2 is greater than or equal to 3x plus 6. I'm going to simplify my left side. 4x plus 6 is greater than or equal to 3x plus 6. Remember to, the only time we flip one of those signs is if we multiply or divide by a negative number. Right now I'm subtracting 3x on both sides. When I subtract 3x on both sides, I do not need to flip the sign. I subtract 6. Once again, a subtraction does not flip any signs. And I get x is greater than or equal to 0. Okay, so when I think about that number line, it means I would start at 0, and I'm greater than or equal, so I'm going to go to the right. Okay, so for my interval, my left bound is 0, and it is included because of the equal to, and then I'm going to go to positive infinity on my right bound. So my final answer is 0 to infinity. All right, wow, number 8 looks kind of like a doozy here. Let me give you a hint on 8. Let's get a common denominator first. Okay, so I'm going to put 2 over 1. 6, 1, and 12. Common denominator. How about 12? So that means I'm going to multiply the top by 2 on this one. That means I'm going to multiply 2 times 12. Greater than or equal to, and I already had 12, so I don't need to do anything on the right side. All right, now, using our trick from solving equations earlier, I'm going to multiply by the common denominator, which is 12. And the great thing is that cancels all of them. So they're gone in the bottom. So across the top, I'm going to distribute my 2 in my first term, so I get 8x minus 6. 2 times 12 will give me plus 24, is greater than or equal to 2x minus 1. I get 8x plus 18 is greater than or equal to 2x minus 1. Subtract 2x. I don't need to change my inequality sign since I'm subtracting. Subtract 19. And here we thought we were going to get a pretty number, right? Nope, we don't have to get pretty numbers. I'm dividing by a positive 6, so with a positive division, I do not need to move my sign. I'm going to leave it just as a fraction. X is greater than or equal to negative 9/16. Again, it's not a huge deal that I have a fraction because if I think about it, I find negative 9/16 on my number line. Oh, look, it's right there. By the way, 0's on this side. We know that much, right? And it's greater than or equal to, so I'm going to go to the right from it, and it looks like it includes it, so I get a nice bracket right there. So in interval notation, my final answer is going to be negative 19 over 6 as my left bound, all the way to positive infinity for this inequality. Okay, bottom of the page here, I'm solving compound inequalities, okay? Remember, compound inequalities means I see my inequality sign more than once, okay? The 2 I have here, these are and ones. We have 2 different options here. I'm going to do them 2 different ways here so you can kind of see. It kind of depends how well and fluid you are with your math and if you can be careful, okay? But what this is saying is this expression 2x minus 1 has 2 conditions. So either negative 11 is less than 2x minus 1, and I shouldn't say either, it's an and. 2x minus 1 is less than or equal to negative 5. So you can take that middle and you can split it into 2 equations, or in this case, inequalities, okay? So I'm going to do this way. I add 1. I have negative 10 is less than 2x, divide by 2, and x is going to be greater than negative 5 here. On this side over here, add 1. I get negative 4, divide by 2. And remember, I'm dividing by a positive 2, so I don't flip the sign, okay? Now, I can join these back together. Negative 5 is my smallest number. Negative 2 is my larger number. If you think about this, these should kind of match up. That I want x to be bigger than negative 5, so I am going to change some colors here. I'm going to go this way, okay? And I want x to be smaller than or equal to negative 2, so I would go this way. And I need, anytime this is an and, I need an overlap, okay? And is an overlap. I need to know where they share that because x needs to stay within both of those. So my answer would be between negative 5, oops, I need to fix. On this left side, I did not have an equal sign, so it's going to be a parenthesis. Make sure that's a parenthesis there. And negative 5 to negative 2. And the negative 2 gets a bracket. okay? Now, one of the things on these kind of equations, to be honest, I really didn't need to split, okay? I am going to leave it in blue here. So if you are comfortable with this, you can do all the work. Just know what happens to the middle has to happen to both the left side and the right side. So if the first step I'm going to do is add 5, I need to do it on the right and I need to do it on the left. So that'll give me 2 is less than or equal to 2 over 3x is less than 4. Okay, now I need to get rid of that 2 over 3 on the x. So that means I'm going to multiply this by 3 over 2, which means I want to multiply this side by 3 over 2 and this side by 3 over 2. In the middle, 3 over 2 and 2/3 cancel, and I'm left with x. I did not multiply by a negative, so I do not need to flip my signs, but now I'm just going to do the math. 3 times 2 is 6, divided by 2 is 3. 4 times 3 is 12, divided by 2 is 6. So x is between negative or positive 3 and positive 6. Okay, so on a number line, if I look at that, here's my 3, here's my 6. Once again, my signs are different, my inequality signs. That means I'm including the 3 and going to the right, but I'm not including the 6 and going to the left. So my overlap is between 3 and 6. So as an interval, I would write it 3, 6, bracket on the 3, parenthesis on the 6. And we have one more page here. Okay. Now we're going to add absolute values into our inequalities. Okay. And once again, if you remember from P.7 when we solved absolute value equations, we have to do a split and give 2 different answers. Well, that has a new challenge when you put an inequality sign on there instead of an equal sign. So a couple little things to kind of help you hopefully remember this so you know this. So we have the choice of our absolute value being less than a number and being more than a number. Okay, that's our choice. So if you are less than, and I'm just going to write it like this, you are less than, okay? It's going to be an and in between your two splits, okay? If you have a greater sign, it's going to be great or. Now, you can look at me and say, you're not an English teacher, you can't spell. I spelled these exactly like I wanted to spell them, okay? Because I need you to remember that less than, made with your left hand, is an and, less than. And when you make your right hand into a greater, it's an or, okay? That's what I need you to remember when you go to do these setups. Okay, so on 11, the rules do not change as far as get your absolute value all by itself first, and then you're going to do the split. Do not split it while there's terms being outside or anything like that, okay? So, first things first, can an absolute value be smaller than 20? Yes, there is this small occasion now that you still can get a false statement from the beginning, so always check and make sure it makes sense, okay? But always do that first and then check from there, okay? So we can do this first one. Okay, so that means that my absolute value, so the value inside my absolute value, so 3 times x minus 1 plus 2 is less than or equal to 20. That's a less than, so I need to put and next. 3 times x minus 1 plus 2 could also be greater than or equal to negative 20, because remember that inside value could go either way. So we need to have an and in between when the first original sign is here. So on the second one, we flip the sign of the inequality and the sign of the value itself. Okay, so there's the double change when you do the second one. The first one looks identical to what the first inequality looks like without the absolute value signs. Okay, time to solve. 3x minus 3 plus 2 is less than or equal to 20. That simplifies to a 3x minus 1 is less than or equal to 20. Add the 1, divide by 3, and the first value I get is x is less than or equal to 7. On the right side, different work because we have slightly changed to a numbers. 3x minus 3 plus 2 is greater than or equal to negative 20. 3x minus 1 is greater than or equal to negative 20. 3x is greater than or equal to, gonna make a mistake there, add 1, I get what, negative 19? Divide by 3, not pretty, leave it as a fraction, it'll be fine. And there are my answers, okay? And there's an and in between. So when we have an and, we are looking for an overlap. Let's do a little quick graph, make sure we have that. My smallest number is negative 19 over 3. My biggest number is 7. Okay, so it says at 7, I need to be less than or equal to 7. So I'm going to put a bracket at 7 and know that I'm going to the left. The second one says x is greater than or equal to negative 19 over 3. So negative 19 over 3 has another bracket and it goes to the right. Do I get an overlap? Definitely. I have a good solution. So in my brackets, my left bound is negative 19 over 3 and it goes to 7. In my right bound, both get bracketed. All right, moving on to 12. Quick reminder, you have to get the absolute value all by itself before you can separate your absolute values equations. So first I need to divide by negative 3 on both sides. Okay, so that leaves me the absolute value of x plus 7. That leaves me 9. Be very, very careful. I divided by a negative. I must flip my sign. So I need to flip my sign right now. It was greater than, it is now going to be less than or equal to. This is now my new original equation. I had to alter my first one so it fit the rule, and this is what I base everything on now, my new equation, okay? I'm not going back to the old one. This is the one that everything is going to change from, okay? So my first equation is x plus 7 is less than or equal to 9. Because this is a less than, I have an and in the middle. And I have an x plus 7 is going to be greater than or equal to negative 9. X is less than or equal to 2. X is greater than or equal to negative 16. When I think about that on a number line, negative 16 is smaller, 2 is larger. X is less than or equal to 2, so it's bracketed going to the left. X is greater than or equal to negative 16, bracketed and going to the right. So my final interval in brackets, because of the equal to's, are negative 16 and 2. Okay, so that's my interval. Let me go to the, did not want to do that. But I don't know how to undo it, so we're just going to keep moving, okay? All right, I don't want to erase everything underneath that blue line. Okay, last two here. All right. It's set up a little bit different, but don't let it bother you, okay? In fact, it does bother me. I'm sorry, I'm OCD. I got to move this. And you can move it as long as you go the absolute value of 2x minus 1. Notice it was greater than the 3 before, so I just keep it greater than the 3. Okay, so you're welcome to move them, to flip them. Just make sure that the alligator mouth is still eating the proper thing, okay? Okay, my absolute value is by itself, so I don't need to worry about that. I'm ready to split. So I'm going to do 2x minus 1 is greater than or equal to 3. Notice it was greater, so there's going to be an or in between. 2x minus 1 is less than or equal to negative 3. So again, that flip and the change on the second equation. Add 1. 2x equal to 4, divide by 2, 2x, or just x is greater than or equal to 2. On the right side, adding 1 and dividing by 2, and this is an or. Okay, or is not an overlap, or is everything. Okay, so it doesn't matter what you see, or gets everything. And it has to have the overlap. So on my number line, I have negative 1 is my smallest, I have 2 as my largest. X is greater than or equal to 2. So I get a bracket on the 2, and it goes to the right. I have x is less than or equal to negative 1. So there's a bracket on negative 1 and everything that's smaller than that, okay? This is an okay solution because I want everything. So I'm saying where solutions will fit my inequality and make that a true statement. So on my brackets, or I'm sorry, on my interval notation, I can take any value from negative infinity up to negative 1. Negative infinity is not included. It's a limit, but I don't get there. Negative 1 is included. Then notice I'm going in union with another set that goes from 2 to positive infinity, okay, with my infinity can never have a bracket. Okay, so with or, I can do this. With an and, we would never do this because and has to share them, or can be whatever is appears, okay? Last one here. Once again, make sure your absolute value is by itself first, so I'm going to subtract 4 first. I have the absolute value of 3 minus x over 3 is greater than or equal to 9. okay? Or I could do my subtraction like I just told myself, and how about we make it 5? All right, so now I'm going to try to do my split. This is my official equation that I do the split off of now, the official inequality. So I get 3 minus x over 3 is greater than or equal to 5. It's greater, so it's or. 3 minus x over 3 is less than or equal to negative 5. So, working to get x by itself, subtracting 3 first. Negative x over 3 is greater than or equal to 2. To get rid of my negative and my 3, I can multiply both sides by negative 3. So I get x, and I get negative 6. I multiplied by a negative. I must flip the sign and make it less than or equal to. Remember, the equal to is there no matter what, but it's the greater than or the less than that flips. So I get a less than or equal to negative 6. On the other side, subtracting 3. Negative x over 3 is less than or equal to negative 8. I multiply again by negative 3 on both sides. So once again, I flip my inequality sign. I get positive 24. Okay? I'm still in OR. Once I start an OR, I'm always stay in OR. So this is whatever comes up, whatever everything I see. My smallest number is negative 6. My largest number is 24. I'm less than or equal to negative 6, so that's going to go to the left. I am greater than or equal to 24. That's going to go to the right. And so my intervals where my solutions are go from negative infinity to negative 6. Bracket the negative 6, it's included. And that's going to be in union with 2 to positive, 24 to positive infinity. Never a bracket on infinity, and a bracket on the 24 because it is included with the equal sign. Have you done all this solving before with inequalities? Definitely. You've done this in Algebra 2. The only big difference in this entire thing is the interval notation. And I will require interval notation on the test. We will use interval notation at great length here in PreCalc. So please make sure you get used to it, and I can't stress enough, smallest number first to the right. We should be able to read interval notation and put it straight to the number line from the smallest to the largest all the way across. Whether it's a union or whether it's just one, it should always be smallest first all the way to largest at the end. Practice. Page 126, 3 through 90 by 3s. Do the odds. Check with Slater. Doesn't matter to me as long as you understand and practice. Good luck.